So here we're going to go over 3 examples of calculating moles. The first one is a problem where we're going to convert volume of solution, liters of solution, into moles of solute, in this case NaCl, sodium chloride. The second one is a problem where we're going to convert volume of a gas at standard temperature pressure to moles of a gas. In this case, we're referring to methane, CH4. And the last one, we're going to discuss calculating the moles in a specific number of particles of water. So the first example here, where we're discussing, we want to calculate the moles in 2.5 liters of 0.25 molarity NaCl solution. Now that might seem like a lot, but let's dissect this. Let's try to focus on what we're calculating. We want to convert the volume of solution, in this case 2.5 liters, into moles of solute. So, and I've color coded this here. So the molarity here, indicated by this M, is 0.25 moles per liter. So I want to convert my liters to moles. So I put my liters of a solute on the bottom. I put my moles of solute on top because I want to cancel out my liters. And now I substitute in my molarity. I put in my 0.25 moles for every 1 liter, because that is what this conversion factor means here. This 0.25 right there. That means my moles in 1 liter, and gives me 0.625 moles of sodium chloride. So think about your answer. If 1 liter has 0.25 moles, you have more than double that, because I have 2.5 liters. So in 1 liter is 0.25, and 2.5 liters should be a little more than double 0.25. So in this case, yeah, I have a little more than double 0.5 and 0.625. The second style problem, we have a molar volume of a gas at STP. So conveniently, 1 mole of any gas, ideal gas that is, at 0 degrees Celsius in 1 atmosphere occupies 22.4 liters. So in this problem, I am asked to calculate the moles in 112 liters at STP. Okay, it actually doesn't matter the gas itself. So it could be any gas there. So in this case, we're referring to natural gas, or methane, CH4. So similar to the last one, I'm going to cancel out my volume of a gas, my liters of CH4, and I want to convert to moles of CH4. So now I look to my conversion factor up here, which I've highlighted in purple. So 1 mole of CH4 occupies 22.4 liters. Now, before you go and calculate this, think about what this answer should be. If 1 mole is 22.4, I have 112. Right? That's what I'm referring to. So I calculate that, and I have 5 moles of CH4. Okay. So let's move on. So let's do the last example. The last one, we're talking about calculate the moles in 3.01 times 10 to the 22 particles of H2O. Oops. So in this problem, we're going to talk about calculating the moles of a certain number of particles. In this case, we're talking about water. So I have the moles of particles 3.01 times 10 to the 22 particles of water. And in this case, I want to cancel out my particles, and I want to convert to moles. So I substitute in my conversion factor up here, indicated in blue, Avogadro's number. So there's 1 mole is 6.02 times 10 to the 23rd particles. Always that many particles per mole. And you should get 0.0500 moles of H2O. Now, you should look at this, and it's a good scientific notation exercise here. You have 3.01 over 6.02, which is 0.5, and 10 to the 22 over 10 to the 23 is 10 to the negative 1. So 0.5 times 10 to the negative 1 is 5 times 10 to the negative 2, which is 0.0500 when you account for your significant figures. All right, so those are the 3 styles of 3 more styles of the mole map problems that we have talked about. Okay. All right.